So 14bii is, we're asked now to calculate the energy transferred to the ground during the impact. Now in part I, you should have found out that the velocity just before it hits the ground comes out at 17 meters per second. However, you would be allowed an error carried forward if you didn't get part I correct first. So we need to calculate the energy transferred during the impact. So what we need to look at is how much kinetic energy does it have before, when it's travelling at 17 meters per second, and how much kinetic energy does it have afterwards when it's travelling at 12 meters per second. And if we find out the difference between those two, that will tell us how much energy has been transferred, because energy is always conserved. So if we've got less kinetic energy going up, as we had when it came down, so we've only lost some kinetic energy to the ground during the impact. So let's see how we do that. So first of all, kinetic energy is half mv squared. So if we work out before, that will tell me that I've got a mass of 0.2 kilograms. So 0.5 is my half, multiplied by my 0.2, and multiply that by 17 squared. And then afterwards, we've got again a half, 0.5, multiplied by the mass, which is 0.2, multiplied by 12 squared. Okay, and if we put those numbers into the calculators, let's do the before. 0.5 times 0.2 times 17 squared gives me 28 point. Ooh, don't know what happened there with my decimal place. So that's 28.9 joules, and then afterwards I've got 0.5 times 0.2 times 12 squared, and that gives me 14.4 joules. So if I subtract these two numbers, I'm running out of space down there, so let's do it up here. 28.9 take away 14.4, and that gives me 14.5 joules. Now the mark scheme gives it actually as 14, but I think the reason I've got the 0.5, which would still get you the mark, is because I'm using the 17 meters per second, which is a rounded number. If you were to use the unrounded version, then it would come out, and it would come out as 14. There is another way you could think of this. What you could do is you could realise, well, I've got 15 meters per second. I could work out this kinetic energy, and then I could add on the loss of the potential energy from the MGH, and then subtract the kinetic energy afterwards, and that also will come out as 14 or 14.5 joules.